Okay, this video is going to be called Tryptophan, the amino acid tryptophan, kynurenic acid, and quinolinate. Okay, so what this is about is a couple issues. Number one, can stress make you stupid, make you demented? And can leaky gut make you stupid, make you demented? Okay, so tryptophan is an essential amino acid. We're going to explain this slide right here. I'm going to go through a little bit of a backstory so this will all make more sense. I realize it's kind of a busy, crowded slide, but it's an important mechanism of neurodegeneration. Okay, so again, tryptophan is an essential amino acid. It's one that's sort of held in the lowest reserve. Kynurenic acid is sort of the key metabolite in the pathway that you're going to hear about. Kyn means dog, urenic means urine, and it was first discovered to be in high concentrations in dog urine. Okay. The significance of the pathway is two things. Normally, under normal circumstances, you run small amounts of substrate through it and you produce NAD, nicotinamide adenine dinucleotide. Okay, and that is important for your metabolic pathways, for metabolizing glucose, for producing ATP in your mitochondria. That's normal. So when you have micromolar amounts of quinolinate, good things happen. However, when you have brain inflammation, you produce much larger amounts of quinolinate, greater than 150 nanomolar. So large amounts of quinolinate, and then it starts, instead of going to NAD, it stays as quinolinate and has destructive properties. It's an excitotoxin, for example. It activates microglia, for example, and it's thought to contribute to a lot of psychiatric illness, including anxiety, depression, bipolar, etc. One interesting thing is that phthalates, the estrogenic plastic, will block conversion of quinolinate into NAD. So quinolinate, which is toxic, it causes increased excitability, increased opening of the NMDA receptor, normally a glutamate receptor. So that's rather interesting because remember, I don't know if you remember this, I talked about some paper by Leaky, how he had shown that a lot of these estrogenic chemicals were not just estrogenic. They were not just endocrine disrupting chemicals. They were also neurotoxic. And so what I'm saying is one of the reasons why estrogenic chemicals can be neurotoxic, some of them, like phthalates, is because they block the conversion of quinolinate endotoxin into NAD. So that's actually important to know. I will now go through the backstory so that when I go over this pathway again, it'll make more sense. But what's the point? What's the point of going through all this detail? You don't want leaky gut, so you want to eat your dietary fiber. It's a big deal. Get your fiber and avoid all those things that cause leaky gut because it can lead you to becoming stupid. Okay, and severe acute stress, but more likely, chronic severe stress can also cause this pathway to run more, and it can even become a vicious cycle where it feeds back on itself. A lot of the worst diseases are vicious cycles. It looks like a lot of these things like congestive heart failure and some of these other ones, they turn out to be vicious cycles. So you've got to break out of the cycle. A lot of times breaking out of the cycle means reducing dietary stress, preventing leaky gut, things like that. Okay. So here's the backstory now. Here's the structure of a neuron. Here's the cell body, like the beginning of the neuron, where you've got the nucleus with the DNA. You got the dendrites for incoming information. Dendrite means like the branches of a tree, dendron tree. So that's incoming information. So the incoming information comes into the neuron. If it decides to fire an axon potential, it begins right here. This is called the axon hillock, the beginning of the axon. The axon connects the cell body to the axon terminal. The depolarization, meaning the increased positivity of charge, the less polarization, separation of charge, occurs by sodium channels. They jump over these blocks of myelin. That's called saltatory conduction. These are nodes around the so what happens when you've got the saltatory conduction, you then have the depolarization wave reach the axon terminal, and that opens up these channels right here. These calcium channels are called voltage-gated calcium channels, VGCC. When the calcium comes in, it activates the neurotransmitter vesicles to travel to the plasma membrane of the synaptic cleft, release the neurotransmitter into the cleft, diffuses across the cleft, binds to the postsynaptic receptor, and exerts an effect. That's how neurons talk to each other. Okay, and then I gave a recent lecture where I talked about, is there any hope for these demented patients? And the point of the matter is that, yeah, you can do good things. You can store more glycogen in your astrocytes. You can build more mitochondria in your neurons, use it or lose it. You'll myelinate them more and they can conduct faster. If you exercise more, use these neurons more, you'll build more capillaries in this area. If you got good habits to avoid hypertension, diabetes, you'll have good blood vessels. If you think more, exercise more, you'll form more new neurons. You'll get more new synapses. If you eat your fiber, you'll maintain your tight junctions. If you avoid leaky gut and some other things, traumatic brain injury, your microglia will stay in rest and not be activated. Okay, so there's lots of things you can do to improve cognitive performance. One of the things is to avoid excessive psychological stress, because stress increases cortisol. Same thing with caffeine, same thing with sleep deprivation, and that will send more glutamate traveling along those synapses that you don't want. Overexcites the neurons for no reason. That can cause anxiety. It can even cause depression too. Okay, here's a standard synapse in the brain. This is a standard model of a synapse. It's an oversimplification. It always is, but this is a good way to think of a synapse. First is the presynaptic neuron. That's neuron number 1. Second is the postsynaptic neuron. Here's neuron number 2. It receives the signal, receives the neurotransmitter. The green one over here is the third part of this synapse. So this is a tripartite, part 1, part 2, and part 3, tripartite synapse. And this is the astrocyte. The astrocyte cell is the mama cell, the supporting cell. It will clear the neurotransmitter like the glutamate out of there, okay, and recycle it, send it back as glutamine to the presynaptic neuron. The neurons themselves are the talking cells. They talk to each other, okay. Oh, one thing I wanted to show you about this is cortisol binds to the axon terminal, and it will also stimulate the release of more glutamate. And of course, we talked earlier about the voltage-gated calcium channels releasing more calcium, allowing more calcium to come into the cell to cause glutamate release. And then the stress equivalents that also increase cortisol are caffeine and sleep deprivation. One point I wanted to make is microglia are these cells here that kind of look like a starfish, and they can potentially get involved. They're really like the security guards of the brain. They're immune system cells, okay? And so you could call this a four-part synapse if you include the microglia. Microglia are more common than you'd think. They're like 10% of the cells in the brain. Okay, we talked about this before. In terms of neurophysiology, all roads lead to Rome. All roads lead to calcium. Calcium is where it's at. And this is also why I said neurology textbooks are all stupid. They're basically about as stupid as internal medicine textbooks. Not as stupid as internal medicine textbooks, but just about. They literally will have verily anything. And like my kid for college, he's got the giant Candel textbook of neurophysiology, Nobel Prize winner. And there's hardly almost nothing on excitotoxicity. So people tell me, why do I laugh at university professors and med school professors? Because they don't know the basics, you know. And those are guys who would never invite me to talk, but I'm like their babysitter in terms of knowing stuff about how the brain works. Okay, anyways, here is calcium increase in the cytoplasm. And you can get this for numerous reasons. Ischemia, a lot of things cause ischemia, lack of blood flow to the cytoplasm cells, SERCA inhibitors, mitochondrial inhibitors, traumatic brain injury, cell phone, Wi-Fi, EMF, VGCC. Okay, here's the no pathway of Martin Pall. Okay, Martin Pall, the guy's a genius. He's kind of an Asperger autistic genius. He really is. I mean, he wrote this like 600-page book of small fine print with virtually no diagrams. It's like, I'm supposed to follow that? Thanks a lot, pal. I'm currently reading his paper on the no, another one of his papers on the no pathway. And it's a brilliant paper, but he doesn't make it easy for the reader. Okay, so anyways, lots of things increase cytoplasm, calcium, and you want to avoid them all as best you can. In normal amounts, that's what you need for learning. Okay, here's how a synapse works in more detail. Here's the glutamate released into the synaptic cleft, binds the first receptor over here called the AMPA receptor. That's a sodium channel. Sodium comes in. Because it's positive, it makes the resting membrane potential more positive. It'll move up instead of being polarized at negative 65 millivolts, becomes more positive to like negative 40 millivolts. Then the magnesium, which is positively charged itself, is no longer so attracted because you don't have such a negative charge like negative 65 millivolts. The magnesium pops out of the NMDA receptor, and this then allows calcium to come through. Glutamate, of course, also has to bind the NMDA receptor to make it active, so it's a coincident detector. It has to simultaneously bind glutamate and also have the magnesium pop out. Okay, and under normal conditions, normal amounts of calcium entry into the postsynaptic neuron, that's good. It functions as it should. It does what it should. It'll learn and memorize things if you want it to. That's all good. But you can run into problem. There's other things hanging around here. So here is aspartame, like that sweetener. You don't want to drink that. That'll also activate the NMDA receptor. So something that abnormally activates the NMDA receptor, causing increased excitation of the postsynaptic neuron when it shouldn't be. That's called an excitotoxin. So aspartame is an excitotoxin. Glyphosate sprayed on the non-organic soy, for example, that is an excitotoxin. It's thought that what's happening is it'll mimic the binding behavior of glycine, the small amino acid, which also binds the NMDA receptor. Beta amyloid protein can also bind the NMDA calcium ion channel and cause it to increase its patency. Cysteine too, but it's not as relevant for our purposes at this moment. Anyways, if you get too much excessive amounts of calcium coming in, you can activate harmful protease enzymes like calpain. Cal as in calcium activated, pain as in painful consequences. So that's bad. Okay, here's another example of the things that can happen. When you allow excessive amounts of calcium in here, you can cause abnormal activation of nitric oxide synthase, but this is not our good old friend in the endothelial cells, eNOS, endothelial nitric oxide synthase. This is nNOS for a neuronal nitric oxide synthase, and it can make too much nitric oxide, and the too much nitric oxide, it's a gas, can diffuse into the mitochondria, combine with superoxide anions, and form peroxynitrite. This is the NO-O-NO pathway. NO for nitric oxide, O-NO for peroxynitrite. O-NO, ONOO minus, that is peroxynitrite. And that's a very powerful oxidant. It goes around the cell doing a lot of damage. So you need to know that there's three types of nitric oxide synthase that are worth knowing about. Number one, endothelial nitric oxide synthase. That's what convalescent talks about all the time. In your peripheral arteries, that is your friend. You want that maximized. But nNOS is different. nNOS could be good, could be bad, but for our purposes, it's bad. And then the worst, number three, is iNOS for inducible nitric oxide synthase. You can even think of that as immune system nitric oxide synthase, the one associated with microglia. And when that gets turned on, it's in the setting supposed to be for inflammation, infections, but it'll often get turned on by accident and it'll do a lot of damage. So anyways, the point I'm trying to make is normal function of the glutamate receptors, AMPA and NMDA, is good. We have them going on all day long to learn things, to memorize things, to make us do stuff. But when they're in excessive amounts due to all these toxins, then they're very harmful and they lead to mental illness and brain damage. Okay, a little bit about the gut. Okay, the normal gut right here is this right here. And this is you eat dietary fiber. The dietary fiber is taken by the smiley face, good bacteria. They convert it into short-chain fatty acids, SCFA. The important one is the 4-carbon butyrate. 4-carbon butyrate is taken up by the enterocytes, the gut lining cells. They convert it into tight junctions. These are the tight junctions, these red things here, the TJs. And that prevents bad things from getting across the gut lining. So it's a single cell thick, your gut barrier. And that's what protects you. Okay, let me move myself out of here. All right, now I'm going to show what happens when you have leaky gut. So when you got leaky gut over here, what's happening is that you have a breakdown of the tight junctions. Let's say you don't have enough dietary fiber. You can't make the tight junctions. They can also be broken down by all these things. The antibiotics can get rid of your good bacteria. Oils are toxic to the intestinal lining. Fat, meat, and dairy diets tend to be associated with increased risk of leaky gut. Glyphosate also was originally patented as an antibiotic. It's toxic to gut bacteria. So are some other herbicides. Excessive psychological stress can vasoconstrict, clamp down blood flow to the gut and cause leaky gut. Excessive caffeine can contribute to that. Alcohol is also toxic to the gut lining. Emulsifiers in processed food. Emulsifiers are for sort of combining aqueous and lipid phases, making them stay together in position in a processed food. Fat people and diabetics have increased risk of leaky gut. Polysorbates, like this processed personal care product, chemical, carrageenan also can do these things. BT corn, that toxic stuff. High fructose corn syrup is associated with increased risk of leaky gut. NSAID and aspirin can do this as well. Dishwasher soap. I always rinse my plates off. I don't want any dishwasher soap on my plates. BPA increases the risk of this. There's a lot of things that increase your risk of leaky gut. Artificial sweeteners, carbonated drinks, the phosphoric acid, Al, which is put into tap water, F-, which is put into municipal tap water, Hg, which is a contaminant of high fructose corn syrup, and some other things. XRT, radiation therapy, chemotherapy, traumatic brain injury. When you get leaky blood-brain barrier, you'll routinely get leaky gut barrier. On stroke, they'll also cause it probably for neuronal conduction mechanism. Corticosteroid medications, titanium dioxide, a common thing. It's a whitener. It's in a lot of pills. And if you got leaky gums, you can get stuff across your gums. Anyways, lots of things can cause leaky gut. And what that means is LPS, the bacterial endotoxin, lipopolysaccharide. There's also, this is the gram-negative bacteria endotoxin. Gram-positive bacteria have LTA, lipoteichoic acid. They can get across the leaky gut. Now they get into the blood. They're prothrombotic, increasing the risk of clotting. But they can travel to the brain. And like I said, when there's leaky gut, there's usually leaky blood-brain barrier. They can then get into the brain parenchyma and activate your microglia. Your security guards basically go on alert. And when they bind LPS, to them, that means there's an infection present. So they start dispensing these toxic chemicals to sterilize the area, to kill the bacteria. But the problem is, there is no bacteria. There's just an endotoxin. And now they've released these toxic chemicals on the adjacent neurons, and they damage them. So yes, leaky gut can make you stupid. We talked about how when you have leaky gut, what happens is the LPS and the LTA, they get into the blood, they interact with the blood clotting proteins, the fibrinogen, and it changes from a secondary protein structure of alpha helix to a secondary protein structure of beta pleated sheet, meaning flat. So it goes from being like a cylinder or a slinky, and it becomes like a playing card, and they stack like a deck of cards and bind to each other. The bigger the molecule, as they're all bound to each other now, the more likely it is to precipitate out of aqueous solution, which means to clot. Then these clots form in the blood. They can plug up arteries in your brain and in your heart. It's not good for your heart, not good for your brain. This LPS, LTA, they can get across the blood-brain barrier, and then they're bound by your microglia, and they'll activate your microglia, and that's not good. Okay, so here's a picture of what they do in the brain. They can get across your gut barrier, through the gut barrier, through the leaky, lack of tight junction here. And now the endotoxins will travel in the blood, they'll go to the brain, because you usually have leaky blood-brain barrier when you have leaky gut barrier. They can get into your brain parenchyma, and they can bind to your microglia, and they will activate your microglia. Again, microglia are the immune system cells of the brain. Microglia are your security guards for your brain, okay? So they will then cause activation of your microglia, and your microglia will start to do things. For example, it might turn on iNOS, which is inducible nitric oxide synthase, and that makes tons of nitric oxide. The eNOS in the endothelial cells only makes a small amount for a couple microseconds. The iNOS can stay on for minutes or hours and produce tons and tons of nitric oxide, and then it's a gas. It diffuses around into the neurons, and the same neuron will often be having a little bit of a problem with its mitochondria, and it'll be making some superoxides. Here's a superoxide, O2-, and that will combine with nitric oxide, and they'll form peroxynitrite, this guy right here, ONOO. That's why it's called the no-O-no pathway. Martin Pall figured that out, that genius guy I was talking to you about, the Asperger autism guy. And this will then the microglia is releasing all these toxic chemicals to sterilize the area, and there is no bacteria around there necessarily, probably not, and all it's doing is damaging the adjacent neurons. Okay. All right, this actually was, I'll give you an example of my notes. Like one of the things I do is, I'm so busy, I'll watch videos while I'm eating, and I'll even write notes while I'm eating. It's sloppy handwriting, I kind of got one hand free, I got a napkin over the mouse, but I'm just showing you, these are all these things that can cause activation of the microglia. They're more prone to being activated. The reason why it's a big deal when microglia are activated is they potentially start releasing all these toxic chemicals causing brain damage. So what could do it? When you're aging, as you get older, you become more vulnerable to activation of your microglia. People who take chronic opioids are screwed. They'll often be damaging to the microglia. You don't want to be on chronic opioids. A little bit of sedation during the procedure is probably not a big deal, okay? But you don't want to be on them long term. When I had to go for colonoscopy many years ago, I refused any sedation. And my family made fun of me. They said, "Oh, you enjoyed the colonoscopy?" I'm like, "No, I just wanted to be able to drive my home, be able to do work the rest of the day. And I don't like taking drugs. I especially don't want a benzodiazepine." They're like, "Oh, it's great. You won't remember anything." I'm like, you know what? I want to remember. I don't want any drug that affects my memory system. Okay, sometimes you might need anesthesia, but I can tell you I know a lot of the smartest people in healthcare, and they avoid anesthesia and medications as much as they can. Okay, what else can activate the microglia? A viral infection potentially, black mold, toxic paint fumes, airborne pollutants, diesel fuel, and some people are more sensitive than others. Okay, chronic high corticosteroids as a medication, chronic high cortisol due to chronic severe stress. Okay, the microglia normally are in what's called an M0 phase. And that's the naught mark, and that means they got these big branches. They're like a starfish, and they're sampling everything with their big long branches. When they go into the M1 phase, they become more round. They sort of pull in their branches, and now they're ready to secrete stuff. That's the M1 aggressive active form. M2 is the anti-inflammatory. That's the good one. You like them in this relaxing phase, though, or M2. Anyways, once they're in this active phase, they can release tons of nitric oxide and some other things. So, and they can release inflammatory cytokines and lead to vicious cycles. Okay, so that's sort of the backstory. Okay, now we're back at where we sort of initially started from, but now I think we've got the background to make more sense out of it. Okay, so the way this all starts is you eat your food and you get tryptophan. And tryptophan is an essential amino acid, and it tends to be held in the lowest reserve. There's not a lot in your body. Normally, some of this tryptophan can go down here to protein synthesis, about 5% of it. That's good. Some things that can screw this up, if you've got glyphosate food, too much of it, that can decrease the amount of tryptophan made and available in the gut, okay, because it affects some of your gut bacteria. If you're running too much of this pathway, dietary protein restriction is a way also to reduce the amount of quinolinate. Quinolinate is the bad guy, okay? So we want to reduce quinolinate, all right? But so now we'll talk about some other things that can happen. Tryptophan being an amino acid, like I said, can be made into proteins. That's a good thing. Tryptophan can be made into serotonin. That's a good thing. That's thought associated with a positive mood. The serotonin could be made into melatonin. That's a good thing, like in your pineal gland, associated with being able to sleep better. It's an antioxidant as well. Okay, but now let's talk about the potential problems. You can get activation of this enzyme. We're just going to call it EDO. And EDO will run things like it'll convert tryptophan into kynurenic acid, and that's a good thing by itself. Kyn means dog, urenic means urine, so it's first found in dog urine. And why it's considered good is that it'll inhibit the glutamate receptors, AMPA and NMDA. The R just stands for receptor. So the AMPA receptor is also pronounced AMPAR. MDAR is how we often say the NMDA receptor. Okay, so it inhibits them, so it'll decrease excitotoxicity. That by itself is good, but here's the problem. Actually, no, one more thing that's good. Quinolinate in small amounts, like less than 50 nanomolar, really tiny amounts. This happens normally all day long. You can convert it into NAD, which is important for or NAD phosphate, which is important for mitochondrial function, for metabolism, for making energy. That's all good. You get problems with phthalates and some of these estrogenic chemicals. They can inhibit the conversion of quinolinate to NAD. That's bad because then quinolinate can accumulate in increased amounts and cause trouble. Okay, so now the big thing we were kind of waiting for is why is quinolinate so bad? In large amounts, like greater than 150 nanomolar, when it's present in that quantity, it can function then as an excitotoxin. It'll increase activity of the NMDA receptor, allowing more calcium into the cell, and that increased calcium getting the cell can increase the neuronal nitric oxide synthase, leading to more nitric oxide going into the mitochondria, combining with superoxides, making peroxynitrite, kill the neuron. Okay, it can make calpain, which destroys knock exchanger, kills the neuron. Okay, excessive excitotoxicity can kill the neuron for a bunch of reasons. So it causes problems. It can even also cause the activation of microglia, and thus lead to a vicious cycle where the quinolinate is activating the microglia, and the microglia in the first place were releasing cytokines that led to increased production of quinolinate. So you run into this vicious cycle which just keeps making itself worse and worse. So whenever you see a vicious cycle in medicine, the intelligent thing to do is say, well, how could I prevent this? What could I do to stop this vicious cycle? And here's what you want to do. Exercise, by the way, is good. It makes more serotonin. So exercise does the good thing, makes serotonin and melatonin. That's what you want. All right, so what causes the bad pathway to get run in excessive amounts? Leaky gut. When you get leaky gut, you get the LPS. We talked about that, the bacterial endotoxin. It binds something called TLR4. That's toll-like receptor number 4. When toll-like receptor number 4 runs, you get activation of something called NF-κB, nuclear factor K beta. Okay, so the problem with that NF-K beta is you've got NF-κB. You've got now transcription of more inflammatory chemicals like IL-6 and tumor necrosis factor alpha. These will cause more ETO, okay, more of this enzyme, so you get a vicious cycle. So how do you win that game? I just told you, prevent leaky gut. We went through about 25 things you can do to prevent leaky gut. You want to do all of that. Most importantly, eat your fiber. Okay, what else can do it? Severe acute stress can do it, but it's more of a chronic, prolonged, severe stress. So try not to have chronic, prolonged, severe stress. That's easier said than done, but you can do certain things about it. This is part of the reason why religious people are healthier. If you believe that your life has meaning and purpose, and that you are living for a purpose and a good cause, that you're on the side of good and, in the battle against evil in the world and all that, you're part of the cosmic good, well, then that lowers your stress a little bit. You give it over to God. Okay, God, I got to accept my cross here. I'll just do the best I can with it. That lowers your stress level. That will help you. Plus, when you feel like you're working for a good cause, you're trying to help your child, you're trying to serve a good cause, you feel happier about yourself. So that reduces your stress level, okay? You figure out whatever it takes. Exercise, sleep, they also reduce your stress level. Avoiding caffeine reduces your stress level. You want to do all these things so you don't get into quinolinate overload. If you get quinolinate overload, it'll also do things like, especially if you're iron overloaded, most men over 25 in the U.S., in the Western countries are iron overloaded. Women after 55 in the Western countries, are iron overloaded because all this meat has a lot of iron in it. The processed foods fortify with iron. The free iron, when it gets free, we talk about iron is good. It's a transitional metal with a variable valence. It's good in hemoglobin to bind to oxygen partially. It's good in enzyme active sites. The variable valence is good for handing off electrons. But free iron is bad when it gets loose. It's like Eugene Weinberg had said, free iron is like a fire. You want it in your stove, you want it in your fireplace, but you don't want it anywhere else. So what I'm trying to say is if you've got free iron and it contacts your quinolinate, so people who are iron overloaded, they've exceeded the iron binding capacity of their storage sites, okay, like the intracellular ferritin, for example, and they have some free iron floating around, it can combine with quinolinate and make this quinolinate iron complex that generates reactive oxygen species, ROS, including hydroxyl radicals, and that can cause lipid peroxidation, meaning trash your plasma membranes or your neurons in the adjacent supporting cells. And that can do a lot of collateral damage. It can damage DNA as well. It'll basically kill your neurons, okay? Make you stupid. All right, you don't want your neurons being killed because, those memories in childhood, they're stored on neurons. If you trash your neurons, you could lose those memories, and you can lose your memories of other things. So anyways, there's good news here. Like, what could you do? Like, I didn't just show you this to rattle off a bunch of fancy names and jargon. What's the point? Avoid leaky gut. Eat your fiber, avoid the bad things, okay? Your fiber is your friend of your brain in a big way. Fiber also protects your blood-brain barrier, okay? Consider decreasing your dietary protein, okay? Decrease your psychological stress, get your exercise, do whatever else reduces your stress, makes you happy. We talked about a man who has a purpose feels a lot happier. We went through all the quotes for that, and it's true. So anyways, I thought that was kind of interesting. I hope you found it interesting and useful, and there is things you can do to prevent it.